Okay, 6.1 is introduction to the atmosphere. So this is a dynamic changing on Earth. It's dynamic because there's inputs and outputs that make it sort of not just live in a static state, but sort of change a little bit over time, but still exist that balance, right? You think about the CFCs being created and destroyed, but there's still sort of an average amount of CFCs that protect us from ultraviolet light. And then there's transfers and transformations within the atmosphere as well. This is showing the transfer of energy initially from sunlight, and then you can actually see the greenhouse effect as well. So without the greenhouse effect, the Earth would be a cold, dead planet. And in this case, you actually see no water either. So the atmosphere and Earth's gravity actually holds in the water. And so a lot of planets without an atmosphere or with really low air pressure, when you climb a mountain, the boiling point gets lower and lower. If you don't have any air pressure, there's like no boiling point. It just sort of boils. It's kind of crazy. Another significant idea is that the atmosphere is what creates the climate, and then ultimately that's what decides where the different ecosystems are. Hopefully you remember this from when we created the map of all the biomes of the world. So you can see how the levels of different atmospheric gases might change over time, since it is a dynamic, a changing system. So here's CO2 compared to temperature, compared to sea level. You can see they're all sort of closely related. And then we have our current little spike in CO2. Oh, that's kind of fun. The composition of the atmosphere is mostly nitrogen, N2, and then oxygen, 20%. These values also change. Once upon a time, there used to be way more oxygen. So if you're an animal like an insect, you can only get air basically by exchanging, or you can only get oxygen by exchanging air through your exoskeleton. So if there's more oxygen in the air, you can actually grow bigger as a result. So when oxygen levels were higher, you could see dragonflies with wings that are like 3 feet across and all this crazy, really interesting. And then there's lots of trace gases as well. Even though they're pretty small in percentage, they have a really big effect. And that's why such a small amount of carbon dioxide can have such a big impact. Human activities obviously have an impact on the atmosphere. That's pretty much what the rest of this chapter is about. You can see an example of changes in carbon dioxide over here, how there's the fast carbon cycle, right? And then there's the slow carbon cycle, which we speed up by burning fossil fuels, but we don't speed up by returning them into the ground. Another example of how the stratosphere up here and the troposphere down here are where most of the interactions that we are concerned about happen. The troposphere obviously is where we're hanging out and where most of our weather and clouds and that kind of thing happen. And then up in the stratosphere is where the ozone layer is, only a couple of millimeters, but super important. And every once in a while, a volcano actually will erupt so that the sulfates and other particles go into the atmosphere, which is really interesting. So clouds play a huge role in the albedo effect, just the amount of sunlight that's being reflected, as you see here. Just like when you put on your white t-shirt, the clouds make the Earth feel a little bit cooler. And then you have that great interaction right during the day. They're reflecting that shortwave radiation, which is really high energy. And then they also trap that long wave in radiation, which keeps the Earth warm, right? That infrared is the greenhouse effect. And so this is why we notice in the desert, right, when it's not cloudy, it gets super cold because they're actually acting like an extra layer. Water vapor is, in fact, a greenhouse gas. And here we are at the greenhouse effect, which, I mean, a lot of times it gets bad rap, but actually without the greenhouse effect, the average Earth's temperature would be below freezing and we would all be having a really bad time. It's just the runaway greenhouse effect, as it were. That's more of the issue. But yeah, those greenhouse gases absorb infrared radiation and then sort of jiggle and re-emit the radiation, a lot of which just returns to the Earth, keeps us pretty warm. So some of your skills and applications include discussing the role of the albedo effect in regulating global temperature. And you could think about all these positive feedback loops that happen too, right? The clouds will reflect sunlight, as will the ice, whereas the open water will absorb sunlight. So as more of that ice melts, actually that will warm more, and you'll get less reflection, and the cycle that happens. You should also be able to outline the role of the greenhouse effect in regulating Earth's temperature. Again, good to remember the difference between outline and explain, right? You don't actually need to know like the chemistry behind like the jiggling. It went into a little bit of detail in that video about that, but you should be able to outline, you know, that these gases are what's keeping that infrared radiation in here and making sure it doesn't go out into space. You could imagine without these greenhouse gases, right? All of this just goes straight out and there's none of this returning. And then a few examples of international mindedness. Obviously, the atmosphere covers the entire Earth, so anything we pollute here is going to make its way around. And then a disclaimer, as always, Brad Kramer is the creator of this excellent slideshow, so check out his website for more details.